Hello everyone, I'm Preetika. Now I'm here to explain about proximity measures of data. Proximity measures are defined as mathematical techniques and formulae to access the similarity or dissimilarity of data. Similarity measure, numerical measure of how a like two data objective is higher when objects are more alike, often falls in the range of 0, 1. Dissimilarity measure, numerical measure of often different two data objects are lower when objects more alike. Minimum dissimilarity is often 0. In this proximity measures of data, there are four types: nominal attribute, ordinal attribute, binary attribute, numerical attribute. Let me explain about proximity measures for nominal attributes. Nominal attributes can have two or more different states. For example, an attribute color can have values like red, green, yellow, etc. Dissimilarity for nominal attributes is calculated as the ratio of total number of mismatches between two data tuples to the total number of attributes. Let m be the total number of states of a nominal attribute, then the states can be numbered from 1 to m. However, the numbering does not denote any kind of ordering and cannot be used for any mathematical operations. Let m be the total number of matches between two tuple attributes and let p be the total number of attributes. Then dissimilarity can be calculated by using this formula. I think so it is visible to you all. We can calculate similarity by using this formula. Proximity measures for ordinal attributes. Ordinal attributes have a meaningful order among their attributes values. Therefore, they are treated similar to numeric attributes. However, to do so, it is important to convert the states to numbers where each state of an ordinal attribute is assigned a number corresponding to the order of attribute values. For example, if a grading system of grades has A and B and C, then the number can be given as C is equal to 1, B is equal to 2, and A is equal to 3. Since number of states can be different for different ordinal attributes, it is therefore required to scale the values to common range. Example 0, 1. This can be done by using formula given. Here it is, where m is the maximum number assigned to states and r is the rank of a particular attribute. Proximity measures for numeric attributes. Distance or dissimilarity between two numeric attributes is commonly measured using Minkowski distance, Euclidean distance, or Manhattan distance. Based upon these three formulas, we are calculating numeric attributes. Let me explain about Euclidean distance. Euclidean distance is most popular distance metric for numeric attributes, or also known as straight line distance. It is calculated as by using this formula. Another popular distance measure is Manhattan or city block distance, which is calculated by using this formula. Both above-mentioned distance measures follow the following properties to solve the numeric attributes problem. A general distance measure, Minkowski distance, is given as based upon this formula. If suppose h is equals to 1, Minkowski distance corresponds to Manhattan distance. If h is equals to 2, Minkowski distance corresponds to Euclidean distance. If h is equals to infinity, Minkowski distance corresponds to L infinity norm or uniform form, which is given as here. All the above-mentioned distance measures corresponds to unweighted attributes. However, sometimes attributes can be assigned weights. In such case, respective attributes multiplied to weights. This formula thus becomes. Based upon this, we will calculate the numeric attributes of Minkowski. The above-mentioned distance measures are crucial to the algorithms like k-nearest neighbors, clustering algorithms, etc., and are very widely used in machine learning and data mining. These proximity measures for numeric attributes are very important, and we can calculate the numeric attributes by using three formats like Euclidean or Manhattan or Minkowski. Proximity measures for binary attributes. Let's look at dissimilarity and similarity measures for objects described by either symmetric or asymmetric binary attributes. In these binary attributes, there are two types, dissimilarity and similarity. In this similarity, again there are two types, symmetric, asymmetric, symmetric dissimilarity binary, asymmetric dissimilarity binary. In similarity, there are again two types, symmetric, asymmetric, similarity binary, asymmetric similarity binary. For symmetric binary attributes, each state is equally valuable. Dissimilarity that is based on symmetric binary attribute is called symmetric binary dissimilarity. If objects I and j are described by symmetric binary attributes, then based upon this matrix, we are give the values to the QRST values. Dissimilarity between I and j is this, and it is also called as dissimilarity of symmetric binary, and this is the dissimilarity of asymmetric binary. Based upon these two formulas, we can calculate the binary attributes of dissimilarity matrix. Complementarily, we can measure the difference between two binary attributes based on the notion of similarity instead of dissimilarity. For example, the symmetric binary similarity between the objects I and j can be computed as similarity is equals to of this formula. The coefficient of similarity I, j of equation is also called as Jaccard coefficient, and this is popularly referred as literature. Proximity measures for mixed attribute types. Real-world data is often described by a measure of different types of attributes, so it is important to define proximity measure for such data. One approach is to group each type of attribute together, performing separate data mining, for example, clustering analysis for each type. This is feasible if these analyses derive compatible results. However, in real applications, it is unlikely that a separate analysis per attribute type will generate compatible results. A more preferable approach is to process all attribute types together, performing a single analysis. One such technique combines the different attributes in a single dissimilarity matrix, bringing all the meaningful attributes into the common scale of the interval. So by using this formula, we will calculate the single dissimilarity matrix. Based upon these rules, we will calculate the single dissimilarity matrix. All the steps are very similar to what we have already seen, and numeric attributes is normalized to 0, 1 for some reasons. This is all about proximity measures of data, and thank you for giving this opportunity.